Hello, greetings. Hope you guys are good. And in today's video, we're going to be doing exam type questions for probability. So without wasting any time, let's get straight into it. The question says, an entire sample space is made up of two complementary events, S and T, where the probability that is not S is equal to 0.33. So it says complete the statement. Now, before we get to 1.1, what's the definition of a complementary event? Complementary events are events that are mutually exclusive. In simple English, what that means is that both of these events can't occur at the same time. For one event to occur, the other one has to stop or has to not occur, right? So they can't occur at the same time. So back to the question, it says an entire sample size is made up of only two events. So it says complete the statement. If a sample size is made up of two events that are complementary, in other words, they are mutually exclusive and they are also exhaustive, meaning there aren't other events that can occur. It's only these two. The probability of both of these events is equal to 1. Now they say write down the value of t, right? We already know that because it's only two events, if it's not S, it means that you can also write this as T. So the probability of T is 0.33. Let me use a different color. Moving along. So question 2 says, a survey was conducted among 180 residents of a small town to establish how many people have contacted TB or HIV during the last 5 years. X amount of people, so an unknown amount of people were diagnosed with TB, 69 only with HIV, and then not only with, but yeah, and then 51 did not have both of the diseases. So we have to represent this in a Venn diagram. How can you represent this in a Venn diagram? So circle A will represent all of the people who have TB. Circle B will represent all of the people who have HIV. Sorry. And then all of those who don't have the virus, who don't have TB, or who don't have HIV, will fall outside both of these circles. Now, going back to the data that was given to us, how many people do not have TB or HIV? It's 51. How many people have both HIV and TB? It's 30. How many people have HIV? It's 69. But we've already counted for 30 who have HIV and TB. So how many people only have HIV? It's 39 because it's 69 minus 30. How many people have TB? TB only, it's X amount of people. But from X, we have to also minus the 30 who have TB and HIV. So in this part, you only have 30x. So we have to calculate the x here, right? And that's literally the next question. So how many people have contracted TB only? So in this section, right? You're gonna say the sample size consists of 180 people. Of those 180 people, 51 of them don't have TB or HIV. 30 of them have both TB and HIV, plus X minus 30 of them only have TB. And then 39 of them only have HIV. So if you add all of these numbers together, if you remove the brackets, you're going to be left with 51 plus 30 plus X minus 30 plus 39. So we have plus 30 minus 30. Both of them cancel out each other. So you're going to be left with 51 plus 39. 51 plus 39 is equals to 90, right? And then you're going to take that 90 and you have to move it to the other side so that you group the like terms together. It's going to be 80 minus 90, which is equal to x. X is then equal to 90, right? So for us to find out how many people only have TB, where there's x, right, here, you're going to substitute it with 90. So you say 90, which is your x, minus 30 is equals to 60. And these are the people who only have TB. Right. Now let's move on to the next question. Now you have to calculate the probability that a person is selected at random, right? Meaning who only have been diagnosed with TB. What's the probability of that happening? The keyword here is only. There's only 60 out of 180 people who have TB. That's your probability. But you can simplify it. And if you simplify it, what's 60 out of 108? That's 1/3. That's the probability that a person is only diagnosed with TB. So what's the probability that a person will have neither one of the viruses? It's equals to 51, right? You have to refer back to the Venn diagram. I'll put the picture of a Venn diagram here. And then there you have it. Unfortunately, this one, I don't think you can simplify because they don't have a common factor. So yeah, that's all I have for today. I'll probably post part 2 soon. But yeah, with probability, it's very important that you learn your definitions. It's important that you know what a complementary event is, what's a mutually exclusive event. It's important that you also learn how to draw your Venn diagrams. In most instances, if you're given scenarios and you place everything within the Venn diagram, it will be easier for you to answer the questions. But otherwise, that's all I have for today. See you guys in the next video. Peace.